basic idea of this is that you're going to put a more concentrated mixture into the tank.
Right.
You're doing houses that are
about 6,000 square foot.
okay. On average, and that's what the larger machine's for, right?
Right.
And then this one's going to be more for the individual
smaller
bays.
one.
Okay. So when you're doing 6,000 square feet, that's going to require a minimum of 2 liters of water. All right. You have a 7-liter capacity in this tank, so you can always use more water, and potentially more. It depends on the volume of plants, and we should probably talk about how big the plants are getting, and and what you're actually doing with the plants. The 10,000 square feet, the amount of water for 10,000 square feet and the amount of chemical for 10,000 square feet is really based on a general bedding plant product. Okay, if we're growing a lot more foliar mass in that house, we might need to increase it a little bit just to make sure that it's going to do the job right. And we also might want to just add more water to make sure we get more surface coverage with the product. So all the Autofogs work very much the same. You have a compressor underneath the carriage. Both the Mini and the SLVH have a compressor underneath there. You're going to plug in the unit. That's going to run the compressor. And with the SLVH, it's going to run the fan.
Okay.
Because the SLVH has the fan, there's 2 timers, where the Mini Autofog only has the 1 timer because you only have just the compressor running.
Okay.
With this, we have the 2 separate timers because we want the compressor to start later than we've actually started ventilating the house or moving the air in the house. We use the larger unit with the fan for larger areas so we can get better distribution around a larger area.
Okay.
Besides that, beyond that, they're actually very similar. The output for the nozzles is the same. They're both going to output 45 milliliters in 1 minute. And we'll talk more about that because we'll go into calibration of the nozzle. As these things get older, that nozzle will wear, and you're going to want to recalibrate them to make sure that they are properly giving the proper output all the time. But as far as setting it up for use, you're going to put it in a proper spot in the greenhouse. So on a standard, for a 30 by 96 foot house or a 30 by 100 house that you can use the Mini Autofog in, that's going to be generally on a center aisle, maybe 10 feet inside from the door.
10 feet inside, okay.
Okay, that's going to, if you've got HAF fans in there, which is typically going to be a racetrack pattern in a house like that, it's not a bad idea to angle the nozzle 5 degrees off center in the same direction as the air movement would be going. So if the fans are blowing this way and this way back, angle it 5 degrees off so that it's catching that air pattern rather than blowing right into this air pattern.
So you suggest that we keep those little fans running?
If you have the ability to turn them off after the application, if there's automatic control.
After the application, not before.
Yeah, leave them on during the application. It's going to help mix the product around the house, but there's a point where we want that to stop so that the product, we don't want it to settle like this, but we want it to settle like this. And if the air is moving too much, and it also depends on the kind of fans you have. If you've got like a standard cage or a basket fan, those create a lot of turbulence, but they also blow a lot of air down, and they're also very fast.
Right.
So that you can cause some stratification with those. If you use the style of fan that we use is a shrouded fan that's variable speed, so the speed is a lot lower, and the result is that those we don't need to turn off because, one, they're not moving so fast, they're not creating the same turbulence, and we're just trying to create a gentle momentum of air as opposed to air whipping around the house.
The one that we have on the regular cage fan.
Okay.
So they're running really fast.
Yeah, those should go off when the machine's done. Yeah. And so it'll get stirred around fine during the hour that thing is running. Okay, so with both of these machines, as I said, they're going to be 45 milliliters a minute, which means that basically they're going to output 1 liter of solution in a half an hour. So for either of these machines, your output is 1.5 liters an hour. And we always want to exceed that a little bit to make sure that as the viscosity of the solution changes, we're putting 2 liters or half a gallon into the tank. We want to make sure that as we put chemical into that's going to get thicker.
Right.
It's going to be sucked up at different rates. So typically you want to add 15 minutes onto that just to make sure that it dries out, that it empties the tank. All that's running when you're running the compressor, you're basically sucking solution out of the tank. The compressor is an oilless compressor. It doesn't need to be lubricated by the solution like some pumps would be. So if it runs dry, it's fine. It's not going to hurt it.
Right.
So with both of the machines, you have a timer for the compressor,
Right.
This unit, you have one for the fan and agitator as well. Okay, they are both basically very similar to the timers you're going to use when you're setting your lights when you go away on vacation.
Okay.
They are a little different in that you don't pull the pins out with this. You actually flip the pins out from the center to contact the switch.
Outside, yeah.
And that's going to be done for the entire time frame that you want the machine to run. If I only flip the first and the last one out, it's going to run for 15 minutes and then run for 15 minutes at the end.
Right.
So all of these pins need to be out during that time of application.
Okay.
With this unit, you have a manual or an auto switch. It's a 3-position switch. So when it's plugged in, we could just turn it on by flipping it to manual.
And then it'll go.
And it runs right away. Auto is going to run off of this timer.
Okay.
Okay? With fan and agitation, that's the same thing. So the first thing we're going to want to do with these is get them set to the correct, basically synchronize the two.
Right.
So this one says that it's it's 1:45, and this one says it's 1:05.
Okay.
And actually, yeah, they're on. It's a 24-hour clock. Important to know because we don't want one turning on at 7 a.m. and the other one turning on at 7 p.m.
Right.
So when we get this right, I'm going to get this to match up pretty closely with the other one, and I just do that by turning the body. Now, the compressor, we don't need running the whole time the fan is. The fan on this machine is going to run the fan and the agitation. So it's a good idea. Typically, we want to run this for about a half an hour before the compressor turns on.
So it's going to mix the stuff.
It's going to mix it up, but it's also going to it's going to start blowing the air around the house in the pattern that we want to work with this machine. So the idea is we want air to come out of the center, blow down, and come back and get returned into the back of the machine.
Okay.
So what's going to happen is it'll take about a half an hour to really establish that pattern. The machine will start blowing that air around
And mixing
the chemical at the same time.
Okay. That's 30 minutes before.
Yep, exactly.
Okay.
So you've got 30 minutes. Then, so say we want to start fogging at 7 p.m. Okay, this I would start. The timer
6:30.
would be 6:30. This thing, and then so let's say we're doing a 6,000 square foot house. We've mixed 2 liters, and we figure it's not a very viscous solution. It's a very thin. It's a very water soluble product, and we're going to use 2 liters of solution. This we would then set for 1 hour because it's a half an hour per liter.
Half an hour per liter.
Okay. And then we would then add on an extra 15 minutes just to make sure that we drained out the tank.
So we'll run this one for an hour and 15 minutes.
Hour and 15 minutes. So at 8:15, this is going to turn off.
Okay.
We're going to leave the fan running then for another half an hour, just to kind of push the last stuff that got spit out of the machine further in the house, keep it mixing around for a little bit. The particles, when you're creating a machine or a spray from this, the particles are going to stay hanging in the air for several hours. So the machine is creating a droplet that's about 5 microns in diameter. Your hair is about 100 microns. So it's very, very fine droplets. Those are going to float around. So I pushed that in. I'm going to make sure, one thing that's important, okay, this needs to be able to hit the bottom. And you see how it's actually sliced on an angle?
Yes.
It's because we don't want it to get suctioned to the bottom of the tank. Right. That'll reduce the input. So if I look at this right now, this is going to stop about here. So that's not long enough. So you're not going to suck all the solution out of the tank. You're going to come in and there's going to be a level in the tank when you're done. So we're going to push this up. Typically, I'll push it up too high, stick this in until it bottoms out, and then I'll run the stopper down so it holds it in place. Okay, so now you've mixed your chemical. When you mix it in a separate container, you've poured it through the filter. Now we're ready to go. So what's going to happen is your compressor is going to turn on. The air is going to be forced through this nozzle. All right. It is going to come through this nozzle. It's going to get the air is going to come around the outside. And I'll open this up so you can see what's actually happening. This is basically a venturi. Then the air spins in here and comes around this outer ring in the nozzle. Okay, you see this inner piece. That's where the solution is going to come through. And what's going to happen is that the pressure changes as the air goes over this nozzle and out, exits around the outside part here. It's going to siphon the chemical from this tank, and it's going to atomize it when it hits that airstream because it's a very high velocity airstream. So we screw that cap back on. Oops, sorry. And now one thing that's really important, if you look on the side of this, And you can see it better on this one because it's out. There's a red dot and a red line.
Right.
Okay? This needs to be finger tight and then brought back so that red dot and red line match up.
Okay.
That's calibrated for 45 milliliters a minute out of the factory when it's brand new.
Correct.
That will change as
the nozzle worn out.
As what's going to wear in the nozzle. The solution's never under pressure. Okay? It's going to be the air slowly wearing away at the body of the outer ring. As that starts to get wider, okay, that's going to let more air exit. It's going to decrease the pressure. You're going to start siphoning less chemical. As you start to see, I mean, really, you should be looking at it probably annually, checking the calibration. And you can do that. The machines all came with a 100 milliliter graduated cylinder. Okay, so you've probably got one around. You got a lot of machines. You want to measure the flow through the nozzle. Generally, I do it for 2 minutes, just and see how much it siphons out. It should be around 90 milliliters for 2 minutes, and you can adjust that back into shape by, in this instance, if it's worn, you're going to tighten this up a little bit, and it's not going to take much. If we turn this nozzle when it's running, you'll see the volume of output change visibly. You can see that, oh, it's putting out more, it's putting out less. So all we have to do is just adjust that a little bit each time. We're going to have to add, because that's what that's going to do, is it's going to put that outer ring in closer, creating a tighter distance between there, and it's going to generally get it back into spec. That generally we can do that for up to 10 years before we see a replacement nozzle needed, unless some damage is done to the other parts of the nozzle. Okay?
So that this one has the same thing then?
This is exactly the same nozzle in there with just some different body parts.
Yeah, it is.
Can you see?
Now,
Oh, this one has to be.
Oh, I see the red line there.
You have to put it back.
Now, why don't you take that cap off while you're twisting it? Because I want to show you again another thing. Now inside here, there's an O-ring.
Right.
Okay, this entire system relies on proper air and then the proper amount of solution coming out for it to work. If the solution lines are clogged, it's not going to put the right amount of solution out. And if there's something wrong with the air, meaning there's either a leak in the air or there's a clog in the air, it's not going to work right.
Right.
So we want to make sure that the air system is completely free of clogs and leaks, and this is one of the spots right here where it'll happen first. You've got an O-ring in there.
Right.
It's not going to really come in contact with chemical too often because the solution's being siphoned right through, but over time that's going to wear. The machine came with an extra one of these, but this should probably be replaced annually.
The O-ring.
The O-ring.
Right.
Yeah, it's really easy. Just someone pries it out. You've got maintenance guys that just pull it right out. That's one thing that should be done annually, is just replace that O-ring. Right. That's a very simple thing. And then probably do the O-ring replacement and then calibrate after the O-ring replacement. Okay. Because if air is escaping, you're not going to get a proper read on how much chemical's coming out.
Right.
Because that's probably the first thing I would say is, really it'll probably take 2 or 3 years for the nozzle to be worn to the point where it'll change. Mm-hmm. You want to look for air leaks and stuff as a result. So anywhere that air is coming out of this, and that's why we have on the front of both.
This really back up quite a bit compared to the other.
Huh?
This one backs up quite a bit compared to this one.
The red line?
The red line, you have to go a lot further.
Back, yeah, exactly.
Would that be a sign that maybe your O-ring is a little bit worn out?
Potentially, yeah, exactly. It also, they're machined so that there can be a slight change to the way that was turned. Okay. They're machined and then they're tested to get to where that red dot and red line are. Okay, so the other if you look, both of the machines have a gauge.
Okay.
The gauge is really only important for one reason. That's a diagnostic tool.
Okay.
If you call us up and say, my machine's not putting out all my chemical, I got a whole bunch left in the tank, and the timer's running fine, first thing we're going to say is, okay, is there an air leak?
Right.
If there's an air leak, this will be, this should run between 16 and 25 psi. The little line should be around, the 19.
20, something.
Exactly.
20, okay.
It's going to jump around a little bit because it's a air compressor and there's a little pulsing in there.
Right.
The hose will actually dampen some of that going to the nozzle, but right at the compressor where this is measuring, it's going to kind of vibrate a bit. If this is down around 10, there's a leak. There's no pressure building. If it's really high, if it's around 30, you got a clog. Okay. So those are things that we'll ask you right away. Okay, what's happening here? Those are things that you can look at to test it. Now, with the larger machine, this ring is important.
Okay.
Okay, you want to put that back on and in place. This is actually a parabolic reflector.
Okay.
There's an ultrasonic noise created here when the air nozzle is exiting the air is exiting the nozzle. That noise is being reflected back at that tip. The intent of that is to vibrate those droplets so that they don't recombine very quickly as they come out of the machine.
Okay.
The result is, when I compare this machine to that machine, this one will have a particle size range. When we talk about particle size, 5 microns being the average particle size, that's a volume mean diameter. Okay, so it means that half of them are bigger than that, half of them volumetrically are smaller than that. The other thing you don't hear in that number is the range of particle sizes. This machine has a range of little less than 10 microns to submicronic, meaning that everything that comes out of this machine is less than 10 microns. There's other machines that will have different methods of creating droplets that'll have. They might say we've got a 5 micron average, but they might have 20 micron droplets coming out of it.
Right.
We don't want big droplets. We want the droplets to be as even as possible so they'll evenly distribute around the house. The bigger the droplet, the faster they fall. So we don't want them. We don't want pesticide being laid out on the ground. We want it spread around the house. That ring helps with this. This machine doesn't have it, and that actually it gets to about 15 microns is the range on that. It's still small, but when we're dealing with larger areas with this, we want to make sure. That's why the ring is on the machine with the fan. Exactly. We want it to travel and hang longer because we've got a larger area to cover. It's not as critical with this only doing 3,000 feet. Okay, so we've mixed the chemical, we've put it in there, it's run through, it's come out. The types of things you want to do for maintenance on this machine. Obviously, you're going to clean the tank well, triple rinse. It's very easy to take out. The Mini Autofog, the same way, it just pulls right out of the top. You are going to want to take warm water. I generally would take a cup, just a plastic cup of hot water, and you can take the solution line out of the chemical tank and just hook the compressor up, let it run, stick the solution line into the hot water tank, let it spray for a minute. Wearing a glove, cover the nozzle with your thumb for a second. That's going to push air back down the solution line, pushing it back into the cup. Do that a couple times. Pulse that a couple times. So it's going to take hot water in, and then you're going to blow it back down.
So we clean up the line.
Exactly. The intent is to clean this up, because we said it's filtered going into here, it's filtered coming out of here, but you're slowly pulling solution up that line. And what can happen over time is, just like silt in a river, stuff that's in there that's not really dissolved well can deposit, especially in the bends of that tube. So after a year, this tube is not going to look as clean as it is. We want to prevent that as much as possible. When this tube starts looking gunky, rather than trying to clean the tube, replace it. It's a very cheap part. It just connects, as you see up here. It's just a compression nut on there. It's very easy to replace. So you want to replace that probably annually when you're doing O-rings and stuff. But anytime you notice it getting gunky, that's when you're going to start having problems, is because something in here can flake off and end up in this tip, and then it won't siphon properly.
The O-ring that's in the tip, is that standard, or we have to get it from you?
I get it from us. It's a metric-sized piece. The nozzles are actually made in Japan for us.
Okay.
So, but we have those, and like I said, each one of the machines should have come with one of those O-rings. Okay, as far as other cleaning, both units have a air filter right here. Okay, it's right there, and it's on the back side of this one right here. Okay? And that's a real simple piece. It's basically, you're going to pop this open, pull it out. Now you can see there's already some gunk on this.
Right.
It's about time to start cleaning that. Because what's going to end up happening is this starts to clog up. You're not getting much air into the machine.
It's called the clogging port that we're talking about.
Exactly. If the machine's not getting enough air, it's not going to provide enough air to the nozzle. It's not going to work right. Eventually what will happen, I had a customer that came in that had a bunch of machines and they said, well, neither of them are working. We're so glad you're here. Look at them and tell us what the problem is. We turned them on, and all of a sudden air is just pouring out from under the machine. And they said, well, see, it's not working. I said, well, yeah, and that's why. I said, did you ever clean the air filter? And they said, what air filter? I said, okay, well, the problem is that over time, the air filter got so clogged the compressor has to work harder to try and suck in the air it's supposed to be pushing out. What ends up happening is underneath this compressor, this cover, there are airlines, plastic airlines in a compression fitting running to this and then running to this fitting.
Right.
Okay? What happened is the compressor got so hot that typically what will end up happening is you'll start to melt the tube right at the base of the compressor, so it splits, and now all the air is coming out there and not out the nozzle.
Right. So when the machine is running, we should have no air coming out of nowhere.
No, exactly. It should be coming out of here. And in fact, if I cover up this, it'll start going bup, 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 bup. There's a pressure relief valve on the compressor.
Yeah, so it doesn't go over certain
Exactly. So, and you should not be exiting air anywhere else. And you'll know that by what the gauge is saying.
Okay.
So this should probably be every 3 to 4 times someone should be taking this out, looking at it, cleaning it. You know, that's starting to get a little gunky in it. You can see where it's actually getting gunky. It's getting gunky right where the holes are. Right where the holes were.
So just soap and water?
Soap and water, let it dry before it goes back in.
Okay.
Okay, and they have the same piece. Yeah, I mean, it's just keeping it clean. Once it starts to fray, get a new one.
Right.
It starts to get junky. We don't want to have pieces of the filter get sucked into the compressor. So, for the most part, if you're cleaning the nozzle and you're cleaning that filter, that's really all the maintenance got to be done to this on a regular basis. We're going to need to look at O-rings and stuff on an annual basis, but the regular, you know, every operation to every several operation things are those 2 parts. The other thing that I would suggest to you is that keeping the entire machine clean, in our opinion, in our experience, leads to these types of things being cleaned more regularly too. When I come in and I see a machine and it's covered with gunk, that generally means they're being sloppy with other care on the machine as well. Okay. And the way I always explain this to the guys that are using it is, okay, this machine is saving you from coming in here at 7 p.m. and spraying for 2 hours. You want to take care of this and make sure that it's running well and it's happy and it's being maintained well, because when it's not, that means you're showing up here at 7 p.m. to go spray the crop. And nobody likes doing that. So, do you have any questions as far as how to set the machine up for use?
I see those red here. Is that an adjustment to the fan? Or?
This is, for this, really you're not going to ever need that. That okay. You can adjust, this can allow you to adjust this, basically the deflector in there to make it funnel upward a bit. Right. It's not something you're going to use.
Okay.
Because really, in this type of application we're doing, we want it to go laterally as far as possible.
Okay.
We want to travel the length of the house.
The length of the house?
Yeah, we want the air to go down the length of the house and come back.
See, the greenhouse that we have, the walkway is the width.
Okay.
So
there's no other walkway?
If they are by the side of the greenhouse.
Okay.
But not in the middle.
Okay.
So we'll have to show you.
Yeah, let's talk about placement. Let's go visit a couple of those and we can talk about placement. Generally, we want it going with the air movement in the house and not across gutters. The problem with across gutters with this fan especially is this is going to blow out, air's going to be going like this. Yeah. If it hits a gutter at maybe, your gutters look like they're about 10 feet maybe. Yeah. So what can happen is you'll hit the peak, and the gutter is going to reflect air downward, and it's going to not allow all the air to go through. It's going to shorten up your distance of throw. You're better off working with the natural air movement and the natural patterns that are going to be created by the way a greenhouse is situated.
Okay.
Okay. As I said, as far as mixing for this, the manual talks about it, but I've got a spreadsheet that I can give you as well.
If you can do that, that'd be great.
And then you guys can go through that and make sure that you have proper documentation for each house and each pesticide you're going to use.
Okay.
Okay?
So we can mix liquid or dry?
Both.
Both.
Yeah, as long as the product dissolves, that's fine. One of the things I will tell you is, as I said, you're only going to be doing 6,000 square feet of space, which is a minimum of 2 liters of water. This is a 7-liter tank. That's an 8-liter tank. You can use all of that if you want, and you're going to be the best judge. It's very hard for me to say to you, you have to have so much water. When you're putting a product in here that's going to be very, very heavy, like you're going to use millstop. Okay, there's a product that actually can work in this machine. The problem is the amount of millstop that will actually dissolve in water is fixed.
Right.
Okay, and you're trying to put a lot of this powder into solution. Yeah. For a 6,000 square foot house, You could probably do it, but you're going to need a lot more water to do it. But you're going to be the judge of that because you're going to look at this and say, that's not going through the machine. You can look in that tank and see it's not going through the machine. So you can add water just by doubling the amount of water in there. You'll increase the solubility quite a bit. You've added twice as much water now. Okay? So,
but you diluted the product also.
It doesn't matter. If we're gonna the point is we want to put that amount of active ingredient into a fixed space.
You're doing active ingredient.
Right. So we're trying to put a fixed amount of active ingredient into a space. If we use 2 liters or 4 liters of water, and you would have done 40 or 50 gallons, it really relatively isn't that much more water.
Right.
But comparatively, for the solubility's sake, it actually can make a big difference to solubility, and the goal is to get the product onto the crop.
Right. Okay.
So we're actually doing some testing with Bioworks right now as far as what the maximum solubility, well, they know what the maximum solubility of mill stop is. We're trying to see if we can reduce it a little bit and put it in the machine.
Because that 7 gallon, that will take quite a while.
7 liters. Yeah, so that's 3.5 hours.
3.5 hours. And that machine can work 3.5 hours, no problem.
It can run all day. This compressors that are in here are oilless surgical compressors that are meant for hospital use.
Yeah.
There's no oil in them because we don't want any oil leaking past the seals. Because if it gets here and gets atomized, you imagine what an ounce of motor oil would do to some of your plants. Yeah, so we use a surgical oilless compressor for that reason. They don't require a lot of maintenance either, which is real nice. We don't have to change oil in them. We don't have to do a lot. As long as you're cleaning the filter, the compressors on these things last and last and last. They've been rock solid for us.
Okay. Is that right?
Okay.